Hey all, welcome to homeschool and we are with class 11 chemistry series. I started with the second chapter, structure of atom. First chapter is already covered. Videos link is provided in the description. If you have not yet watched, please go and watch. And already one part of this chapter, that is structure of atom, is completed, where I discussed about discovery of electrons and also charge to mass ratio of an electron, right? So we studied the three important values that one must remember about electron, that is charge of an electron, right, found by Millikan's oil drop method. Second one is mass of an electron, and the third value was charge by mass ratio of an electron. So in today's class, we will talk about the discovery of protons and discovery of neutrons. Along with that, we will see few application questions that can be asked on this concept. Especially charge by mass ratio of all these subatomic particles is very, very important. And let's discuss a question on that also. Fine. So let me talk about discovery of proton. Okay, so how did protons were discovered? So can you all recall that who discovered proton that we studied in our lower classes, isn't it? It is Goldstein. Protons were discovered by Goldstein. Okay, say even the discovery of proton was done in a modified cathode ray tube. Okay, so this discovery was done by using modified cathode ray tube. Say that means, let me take a glass tube. We all have an idea about a cathode ray tube, right? So this is a glass tube, isn't it? Okay, so it will have two electrodes, so definitely. And one electrode is connected to negative terminal of battery and the other electrode is connected to positive terminal of a battery, right? And the one which is connected to negative terminal is called as cathode, and then the one which has connected to positive terminal is called as anode. We all know this. And voltage supplied was very high voltage here into the tube, and the pressure maintained was less pressure. Okay, fine. But the thing is, they took hydrogen gas inside the tube. Okay, so they took hydrogen gas inside a tube. Say when high voltage is supplied to this hydrogen gas, they started observing there are certain rays coming from anode to cathode. Okay, so there are certain rays coming from anode to cathode. So let me write the first point, rays from anode to cathode. Okay, fine. And these rays, they called it as canal rays. Initially, they called these as canal rays. It's because they have used perforated cathode here. So this is what we call perforated. That means there were so many holes in the cathode so that the rays would move through the cathode, right? And here there was a zinc sulfide screen. So here they coated this end with zinc sulfide coating. Okay, so this was a perforated cathode. Cathode with lots of holes is called perforated cathode. See guys, these gaps that were made through cathode, they were called as canals, okay, or channels. And the rays, they have passed through these holes, no? That's the reason they called these rays as canal rays. Clear? So that's how you had got a name canal rays, because the rays were passing through canals. So what do you mean by canals? It is the perforations. It is the gaps that is there in a cathode, that was made in a cathode. Clear? Fine. So they started observing the rays passing from anode to cathode, and they also observed that they were having positive charge. So these rays were having positive charge. Okay, positive charge, because you know, when electric and magnetic field was kept, these rays deviated towards negative charge of electric and magnetic field. Okay, so let me write that point. How did they come to know that they are positive in nature? Because these rays, okay, let me write it neatly. These rays deviated towards negative side of electric and magnetic field. Okay, so E is electric and MF is magnetic field. So fine. And now what actually these rays? You know what? They have taken hydrogen gas inside a glass tube and you supplied a very high voltage. So what actually happened was, this hydrogen gas, okay, you had lots of hydrogen atoms, okay, so at high voltage initially our hydrogen gas will break up into individual hydrogen atom, and now each hydrogen atom actually loses, this hydrogen atom loses electron. So after it loses electron, it will become H plus, right? So electron will get separated. It will become H plus. It is this H plus ion which was called as Canal Rays. Okay, say it is this H plus ion that was moving from anode to cathode. It is this H plus ion moved from anode to cathode. Clear? Proton in the sense, it is H plus ion. What do you mean by proton here? You imagine in the hydrogen atom, you have one electron and one proton, isn't it? Say this electron, whatever electron was there in a neutral atom has come out. What is remaining? H plus. It means that a single proton, right? H plus is nothing but single proton. Okay, so it is this H plus that has moved from anode to cathode, and these rays were called as Canal Rays. Okay, so this is what we mean by proton. Clear? So if you take helium gas, you will have positive ion of helium. Those ions would move from anode to cathode. Okay, so here proton in the sense, not the guy that is present within the nucleus is moving. It is the ionized, particles are moving. Okay, so whichever gas you take, that will break down. It will lose some electrons, and whatever the positive ion formed, right? So that is the one which is actually moving from anode to cathode. So you have to remember this point. This is very, very important. So here proton in the sense, since it's a hydrogen gas, it has one electron, one proton. Electron will come out, it will undergo dissociation, it will undergo breakage, electron will come out, only the remaining thing is proton. So that proton ions, this H plus ions, which are nothing but protons, they were moving from anode to cathode. Clear? So this is all about the entire concept. So what I can say is, the very, very important characteristics I am listing out here. So the first characteristic is, the characteristics or properties. Let me write it as properties. Properties of protons, or let me call it as Canal Rays only. Properties of Canal Rays depend on nature of gas here. It depends on nature of gas, isn't it? See, you took hydrogen gas, so H plus ions are formed and they started moving from positive side to negative side. Okay, since they are positively charged, guys, they deviated towards negative side of electric and magnetic field. Okay, say whichever gas you take, that particular positive ion is formed. So definitely the Canal Rays properties depend on nature of gas. So in the last video, when we spoke about characteristic of electron, we discussed that characteristic of electron or properties of electron do not depend on nature of gas. isn't it? Electron is electron only, whatever may be the gas it is, right? But in the proton case, it is completely different. Okay, so the properties of canal rays completely depends on what gas you took it in a discharge tube. So you took hydrogen gas, so you got H plus ions, you called it as proton. Okay, but when you take helium gas, what happens when you take helium gas? Okay, so helium, atomic number 2, mass number 4, right? So it will lose 2 electrons, this helium will lose 2 electrons and you will get He plus 2 ion. You will get He plus 2. If it loses 1 electron, 1 plus. If it loses 2 electrons, plus 2. So helium has 2 electrons, right? So on losing, you will get the ion He plus. It is He plus 2 ions that would move from anode to cathode. Okay, it's not a proton. I cannot call this as proton now. Okay, because it is not a single proton. He nuclei actually has 2 protons. Okay, He nuclei. This is He or helium nuclei. Helium nuclei. Okay, so which has got actually 2 protons inside the nucleus. Atomic number 2 means what? It has 2 protons inside the nucleus and 2 electrons outside the nucleus, right? So whichever the gas you take, that particular positive ion would move from positive side to negative side, and they were called it as canal rays. And what do you mean by proton? H plus ion. Okay, so the ion that has formed from hydrogen, that has single proton. No, that's why that H plus ion itself is called as a proton. Okay, so you must understand the concept very, very clearly here. Proton means H plus ion only, since it has 1 proton inside the nucleus. But characteristics or properties of canal rays always depend on the nature of gas. This is really very, very important. Okay, so that is how protons were discovered. I mean, positive things of the atom were discovered. Okay, so definitely it depends on the different gases. Nature of proton depends on the different gases. Clear? Fine. And now let me talk about the charge to mass ratio. It will not remain constant. See, electrons charge to mass ratio, we studied it was 1.75 into 10 power 11 coulomb per kg. Say electron of any gas, electron of oxygen, electron of hydrogen, electrons property do not depend on nature of gas we studied. So its charge to mass ratio is always a constant ratio. It's always a constant value for whichever may be the electron. It is this much. But what about the charge to mass ratio of proton? It depends, right? Here proton means what? H plus. Okay. So if you take helium gas, it is this nuclei that is formed and its charge to mass ratio will be different, right? So charge to mass ratio of canal rays also depends on nature of gas. Okay. You will not find a constant value. Clear? So this is all about the proton. And now let us go for discovery of neutron. See guys, Chadwick is the scientist who actually discovered the neutron. Neutrons were discovered much recently, that is in 20th century itself. Okay, say how did they discover neutron is, they bombarded thin sheet of, by bombarding. What do you mean by bombarding? It is like hitting. Okay, see, bombarding this onto my hand, in the sense what? I have hit this chalk pencil onto my hand. Okay, so bombarding is just a collision or hitting. Okay, so by bombarding alpha particles onto a thin sheet of beryllium. Okay, so now what do you mean by alpha particle? It is nothing but helium nuclei. Helium nuclei. Say that means helium, which has got 2 electrons, 2 protons, and atomic mass 4. Say if I remove 2 electrons, I will get helium plus 2 ions, right? Say when I remove 2 electrons from this helium atom, I will get He plus 2 ion, and this is what we call alpha particle. Okay, so it's nothing but alpha particle. So these helium nuclei, when I hit onto a thin sheet of beryllium, very special and neutral particles got generated, and they were called with the name neutrons. Okay, so when beryllium was bombarded with helium nuclei, you got a special particles which were neutral, and we called those particles as neutrons. Okay, so neutrons have no charge. They have no charge. In simple words, I can say they are neutral particles. Okay, protons are positively charged, electrons are negatively charged, and neutrons are neutral, right? So how did they discover? By bombarding alpha particles, that is helium nuclei, onto beryllium. When they have hit these particles with beryllium, a new very special particles got generated with neutral charge, and they were called with the name neutrons. Fine. And now let me give a table of information where I will mention charge of these subatomic particles and mass of these subatomic particles in two different units. Okay, so that information is really very important, and try to understand this particular table that I am giving you now. See guys, you can observe this information that's there on a board. See, subatomic particles, electron. Electrons charge in coulombs. Okay, say this charge of an electron, charge of a proton, everything was found by Millikan's oil drop method. I'll come with a separate video on this later once I complete the entire chapter. Okay, so charge of a electron is negative. Say it is minus 1.6022 into 10 power minus 19. Charge of a proton is also same value but with a positive sign. And as I told you, neutrons are chargeless. You have to take its charge as 0. Okay, so this is charge in coulombs. Okay, so these values are important to remember, right? And then relative charge. See, just for our convenience, we can also say that electrons charge is -1, protons charge is +1, and neutrons charge is 0. This is a relative charge. Okay, and compared to mass of these subatomic particles in kg. And these values are also important to remember for competitive point of view. These values can be helpful in calculating many types of numericals. So we all know electrons mass, especially this value is very important, that is 9.1 into 10 power minus 31. And protons mass, you can observe 1.67 into 10 power minus 27. Neutrons mass, you see 1.674. Protons was 1.672. Neutrons was 1.674. Say a slight variation is there between the mass of proton and mass of neutron, isn't it? Say which one has more mass? Definitely neutron has more mass. Okay, here the value is 1.674. Here the value was 1.672. So definitely higher number is this. Very slight increase in mass of neutron you would observe. And mass in unified mass, I can say it is a unified mass, much simple values. This is in kgs. Okay, at the same time, if you want to convert this into AMU, then the values are electrons mass is 0.0005 and protons mass is 1.007 and neutrons mass is 1.008. So slightly higher mass you will find in case of neutron, right? So these are the values which are very important to remember. Say these are very important, and here the mass of these subatomic particles both in kgs and AMU you have to remember. So now let me give a question here. This is a very famous and very common question one must understand for competitive point of view. So the question is, which of the following has highest charge to mass ratio? Okay, which of the following has highest charge to mass ratio? It is electrons. You have to decide whether it is electrons, protons, Option A, electrons. Option B, protons. Option C, neutrons. And option D, alpha particle. You all know what do you mean by alpha particle, right? It is nothing but helium plus 2 ion is called as alpha particle. Okay, so how do you decide the answer? Which of them has highest charge to mass ratio? See, charge to mass ratio of electron is constant. We know its value 1.75 into 10 power 11 coulomb per kg, right? So we know it is constant, right? And what about the charge to mass ratio of proton? Okay, so here proton means H plus nuclei. Proton means H plus nuclei. Remember this. Okay, so what is the charge to mass ratio of proton? Charge. What is the charge here? Charge of a proton is, I'll take a relative value. It is 1, right? And mass, charge to mass, that means charge by mass ratio, right? Charge by mass ratio. So charge is 1 and mass, let me consider approximate value, I can consider as 1. Here also approximate value I can consider as 1, right? So 1 by 1 you got a value 1. Right? And neutrons charge is what? 0. 0 divided by its mass is how much? 1. So 0 divided by 1, it will be 0, right? You will get the answer 0. And what about charge to mass ratio of alpha particle? So alpha particle's charge, alpha particle means it is helium plus 2 ion. So what is the charge here? 2 plus 2 means 2 is the charge. No need to consider positive, negative sign. Just consider the number 2. And what is the mass? Helium's mass. Helium atom's mass is 4, right? Atomic mass is 4. So it is 2 by 4. 1s are 2s are. So 1 by 2. That will be 0.5. Right? So you compare the value. Which one has highest value? Right? So definitely your electrons value is 1.75. Here protons charge by mass is 1. Neutrons charge by mass is 0. Alpha particles charge by mass is 0.5. Right? So highest charge to mass ratio you will observe with electron. Okay. So if I ask you the same thing to arrange them in the increasing order of their charge to mass ratio, how do you arrange? Increasing order I asked you, right? So increasing order means least to highest value. Least charge to mass ratio value you will find for neutron, and later comes your alpha particle, right? And after that comes your protons, and highest value you will find for electron, right? So this is the increasing order of charge to mass ratio. Charge to mass ratio. Right? This is a very famous and very common question. So this is how you must able to find charge to mass ratios. Okay. And remember here, the one which has got a least mass commonly will have highest charge to mass ratio. Right? Say mass in the denominator. The one which has got least mass will have highest charge to mass ratio. Right? Say electron has got least mass. Electron's mass is very less. So that's the reason in case of electron you will find highest charge to mass ratio. Okay, so that is one trick that you can remember, right? Say let me write that the particle with least mass. The particle means any particle here, electron, proton, neutron, alpha particle or whatever. The particle with least mass will have high charge to mass ratio. Okay, so remember this point. So this point can be helpful for you in deciding answers in case if various particles are given. Okay, fine. So this is again I'm telling you very important concept. Okay, identifying charge to mass ratio. So this entire information that must be there in your head. Okay, so that will definitely help you during the calculation of numericals. So that's all about the today's video. So we completed the discovery of subatomic particles, and then we have seen few application questions. So this is how the questions can be asked in competitive examinations. And in my next class, let me start with various atomic models. So in my next video, I'm going to complete Thomson's atomic model as well as Rutherford's atomic model. So do watch that video and subscribe our channel to learn the concepts in a easiest way. Thank you so much.